Hi there. Welcome to my talk show at Conf42 Site Reliability Engineering. So, today's topic is data engineering in healthcare, how it is transforming personalized medicine and diagnosis. So, data engineering is transforming the healthcare in big way, fundamentally changing the personalized medicine and the diagnostic approaches, and also implementing a clinical settings by creating robust infrastructure. Basically, the data engineering enables comprehensive patient profiles that supports truly personalized treatment. So this also taking care of the foundation addressing complex challenges, which are including the data integration across all systems and also the scalability of exponentially growing information volumes, data governance, quality governance, and advanced analytics requirements. As healthcare continues its digital transformation, data engineering meet evolving challenges related to privacy protection. And this also taking care of edge computing for point of care diagnostics, includes the design for diverse populations and ethical implementations of artificial intelligence in clinical workflow. The foundation of personalized healthcare. So there are certain of the foundations which plays the important role, which are genomic information, the clinical history integration, and the life cycle and environmental data and the data engineering infrastructure. So for the genomic information, the cost of this is going to be like dropped dramatically from 100 million in 2001 to just 1,000 in 2023, enabling widespread clinical approach. And coming to the clinic history integration, this is a comprehensive patient profile incorporate medical records, treatment histories, and the diagnostic result across previously sliced systems, and the lifetime and environmental data. So these are the certain wearable device and environmental sensor providers continuous monitoring, contributing to the 48% of annual growth in healthcare data volume. And coming to the final data engineering infrastructure, this is where the data engineering design complex pipelines to process the data, which is 2314 exabytes of healthcare data expected by 2030. Data collection and integration challenges. Healthcare data is incredibly diverse, from the EHRs and images to wearable and genomic sequences. So each of these, the genomic sequencer, wearable devices, and patient reported outcomes, each with a unique format and standards. And there is also the unstructured clinical information, which is up to 80% of the clinical relevant information, which is exist in the unstructured format, which has to be bring it to the structured format using some natural language processing to extract and the system fragmentation. A single hospital typically manages over 50 disparatable clinical information systems, each with unique data models and exchange prototypes that must be reconciled to create unified patient representation. Data quality and governance. So there is a certain process we follow for the data quality and the governance. Initially is to start with the lineage tracking and the master data management, standardization, and validation. So these are the four steps which are involved in the data quality and the governance. And this will definitely improve the efficiency of personalized medicine, relies fundamentally on pristine data quality. Advanced analytics infrastructure. So the high performance computing, stream processing, MLOps, pipelines, interactive visualization. So these are the four standards that improves the technology which have been used in the advanced analytics infrastructure. So supporting the analytical requirement of personalized medicine requires a sophisticated and a computational resources tailored to the unique characteristics of the healthcare data. Genomic analytic workflow for clinical applications typically requires 120 to 240 CPU hours per patient for comprehensive variant analysis and interruption. Data engineering technologies have demonstrated significant quantitative impacts across various aspects of healthcare delivery. So the natural language processing system now achieve over 90% accuracy in extracting the clinical concepts for narrative text, while implementing data provenance frameworks reduces errors by 35%. So FHIR-based data models, which improves the query performance by an average of 50% compared by traditional relational models. So a well-designed clinical visualization that reduces decision time by 25% and also the diagnostic accuracy by 20%. How the genomic medicine is transforming. So first the rapid sequencing and then the efficient storage and then the automated interpretation and population integration. So these are the four topics how the genomic medicine is transforming, which is available in the current situation. So the rapid sequencing, which the sequence now completed in hours and instead of weeks, and this enables critical genetic diagnosis for critical ill, newborn, and immediate intervention. And the efficient storage. So we have the efficient devices where we can store the data in the current systems. And also the automated interpretations. There are sophisticated varied annotation pipelines, integration filters, millions of genetic variations down to 20 to 25 critically significant mutants for target treatment planning. So data engineering team at leading academic medicine center have revolutionized the genomic by developing ultra-efficient processing pipelines that analyze complete genomics and predictive diagnostic evaluation. So the early warning system predict clinical iteration 5 to 12 hours before traditional sign. And then multimodal integration. This process 250 to 500 variable per patient, including continuous waveform data. Advanced analytics. Apply time series analytics to identify subtle pattern predictive of disease progression. Continuous learning. This automated iteration workflow incorporates new data to maintain model accuracy. So pioneering the healthcare system are harnessing sophisticated data engineering to deploy early warning systems that detect the clinical iteration hours before every patient profile that captures psychological status according to multiple patterns, which unpredicted precision. So these are the four sub bases where we identify the disease and then we take certain actions to protect the patient. And this shows the clinical impact of data engineering. What are the metrics and what is the traditional approach and also the data engineering approach. The diagnostic time has reduced pretty much on a huge number. So before the diagnostic time used to take a lot of time and now the time has come down by 43. And the treatment selection precision based on the data analytics, they can decide how this patient has to be treated. And this information will help the doctor to take 60% more precise, a faster way to treat the selection precision. And the time taken to diagnostic for critical cases. So normally it takes around 16 days to take the necessary steps for diagnostic of the critical cases. But now it takes only 26 hours to take a decision. And the whole genomic analysis, this used to take around 2 to 3 days. Right now it's taking around 8 hours. And the variant review efficiency. So there are millions of variants before. And now, as of now in the market, it's 20 to 50 variants. The treatment outcome prediction. Before, the traditional approach was to see it as a baseline, but right now that is 30% more accurate. And in-hospital mortality is a baseline, and that has reduced by 23%. So right now, what are the challenges in healthcare data engineering? So there are certain ethical implementations and which also includes new designs, the edge computing, the privacy protection, and exponential data growth. So these are the 5 steps which we might cross across in dealing with the future challenges in the healthcare data engineering. And that will definitely help healthcare data to grow at approximately 36% annually, significantly outpacing storage capacity expansions. And also the future of healthcare delivery rests firmly on the shoulders of robust data engineering by building the technical infrastructure that enables personalized medicine and advanced diagnosis. Data engineering are not merely supporting healthcare, but fundamentally transforming it. So their solutions for data integration, quality management, analytics, and ethical implementation creates clear cycles where increased information accessibility drives improved clinical outcomes. So, generating more data to further refine predictive models. As personalized medicine initiative expands beyond academic centers to community settings, the role of engineering will become increasingly central to healthcare evaluations. Thank you very much for taking time to attend this session. Again, this session is again about the data engineering and transforming the healthcare. So, we have a wonderful day. Thank you.